Let's build a package for controlling our Turtlebot. First we'll make a workspace. I'll make the ROS course _w for workspace and cd into that and use the catkin init to initialize the workspace. Then I'll create the source folder inside of that, and inside of the source folder I'll use catkin create package to create our package, and I'll call it turn me round. I want a package or a tool to turn the robot around. Okay, I'll use Atom to edit the two files that it made automatically for me. First it's the package XML that signifies that this is a ROS package, and in the description I'll say tool for turning the Turtlebot round and round. Okay, I'll put myself in as the maintainer of this package and put my name in. I'll give it a MIT license. I'll get rid of these helping comments. Further down there's an author tag, and I'll put in myself again, just copy pasting, there we are, and get rid of all these helping comments. We are not exporting anything, and the dependencies will leave for later. Now in the catkin, the CMake list, we'll put in ROS CPP because we're using ROS C++, and that's basically it for now. Now we'll create a source folder inside of this folder, and we'll create the C++ file that we want to implement this node in. I'll call it round.cpp. So Atom helps me and creates a main structure, and the first thing I'll do is that I'll initialize the ROS node. And in order for C++ to know that there is a ROS namespace that I can init, I need to include this ROS.h. My linter puts a red mark under it saying I don't know where to find this ROS. So I'll, in the client complete file, I'll just find the include path for all the ROS packages, and I'll put it in there. This is only for helping me develop. It's not necessary for actually working with compiling the code. Okay, so now it says there's no matching function for this init. How could that be? So I'll just use the helper. It's kind of slow, but it helps me and says, okay, so you need to put in an arg c, argv, and so on. Oh, yeah, that's right. So so I'll put in the arg c and argv from the main, and I'll put in the name round, and this is optional with the option, so I'll just delete those small typo there. Also, it expects a non-constant argv, so I'll remove the constant. Okay, so now we initialize the ROS node, and we'll make a small while loop that will just keep us running inside of this main function, and we'll run while ROS is okay, and we'll loop at a rate of 10 Hertz. So in ROS there's this rate, and we'll use that. So inside of the while loop, we'll use the loop rate and say let's sleep until we reach 10 Hertz. Okay. So basically that's it. Let's build this package into the terminal, and we'll use catkin build, and it says yes, it worked, all packages succeeded. And then I'll open up another terminal on the ROS core. Okay, let's open another terminal over here, and I'll source the devel setup bash from the ROS core workspace. And I'll say ROS run, turn me around, and I'll tap, but there's nothing there. Why don't we have anything? Oh, that's because we didn't put it into the CMake lists. The CMake list is the recipe for building all our nodes, and we want to have a C++ executable. I'll call it round, and we need to tell it the C++ files that it'll compile from, and that's the that's the round.cpp, and it needs to get the include directories from catkin, and we need to link the libraries from catkin into this C++ file, as I do here. Okay, so let's try again. Oh, it worked. And now I can ROS run, turn me round, round, round. Okay, it says something about, it's ROS time, it cannot work until we made a ROS handle. Did I not make a ROS handle? I did not make a ROS handle. So let's make ROS node, not ROS handle, but NoteHandle, which is a way to work with the actual node that we have in ROS. So I'll compile it. Error. Okay, NoteHandle is not a part of ROS. How can that be? I only put one colon, NoteHandle, NH. There we are. Let's build it. Fail again. Okay, so now it is still not a member of ROS, but I did put in 2. So let's see what the linter how can help me. I said node handle. Yeah, there it is with that capital H. Alrighty. Save it, build it again. There, it worked. Okay, so let's run it. And now nothing, no errors there. And if we say ROS node list, we'll see that the round round is running there. Okay, Control C, ROS node list again, and there's no round round. Okay, so we can start it and we can stop it. That's fine. Now let's make it do something. So we'll ROS launch our Turtlebot Gazebo simulator. So now we're in Gazebo and we have our Turtlebot here, and I'll just zoom in a bit so you can see it. It's right there. Okay, and let's open the keyboard tailor operation node, Turtlebot tailor op keyboard, and now I can use my arrows to move it around. As I'm pressing the U button, the Turtlebot is moving around in a circle. Okay, so what's actually going on here? Let's use the RQT graph to see how things fit together. This is the default way of looking at it. You can see Gazebo is running Turtlebot, and we have the Turtlebot tailor op keyboard, which has a line into the Turtlebot basement nodelet manager, which is actually the base of the Turtlebot. Now, switching to the nodes and topics, the topics are in these boxes. So you can see actually there's several tailor op, command velocity inputs. The tailor op, the safety controller, and also there's these outputs from the node, the mobile base, the velocity, the bumper, and so on. So what we want to do is we want to make a line that goes into this mobile base, and that line is going to be the commands for the velocity. I want it to turn round and round, right? So I'll kill this Gazebo, and I'll actually open it again because we didn't really see how it worked. So ROS topic list, you can see that's all the topics that, all the lines and all the boxes that we had. And we have all these inputs. And I want to use this input navi because I'm making a navigator for the Turtlebot. So let's ROS topic info command velocity input navi, and says this is a geometry twist message. So let's figure out what this is, this geometry twist. So first wiki ROS.org, yep. And I'll just search for geometry messages. There it is. Actually, the geometry messages is a, Gazebo, something went wrong. Okay, so it is actually a package that has several of these messages. And inside of the twist message is a linear and an angular part, and that linear and angular part has an x, y, and z component. That's actually made up of vector 3, also in geometry messages. Okay, so we need to actually create a publisher that publishes this kind of message onto this graph. So first I'll say I want a ROS publisher, and I want to call it velpub, but actually how is it actually that we create a publisher? So I could use the linter for it, but I'll show you another way. So wiki ros.org again. ROS CPP is the C++ implementation of ROS. You can go to the tutorials, how to write a simple publisher and subscriber, and there it says, okay, you can make a publisher like this. Another way to do it would to go to the ROS CPP package and click the code API, and there you have all the actual code, and there's really a lot. But what we want to do is that we want to say publisher, advertise, and we want to use this one up here. It looks like that, and it has like, this is an example. Okay, so I'll do that. My velocity will be equal to the NoteHandle. On the NoteHandle we'll advertise, and how does it advertise? Oh, so we'll say which kind of message we want to send. We want to send geometry message twist, and we want to send it onto the topic. It's a string, of course, so command mux input heavy. Something's wrong there. Command velocity mux input heavy. So there, and we want to send only one at a time. Okay, so now we have our publisher, and it says, oh, there's something wrong. That's because it doesn't know about the geometry message. So we need to include the geometry message. Geometry messages, and just like ROS, it's in its own little folder, so geometry messages /twist. So, wait. So there's something wrong with both my linter and my Gazebo, it seems. Okay, so now we have the geometry messages twist, and now we need to publish that at this rate of 10 Hertz. So we'll say well pop and publish a message, some message. So I need to construct this message, and I want the Turtlebot to go round and round. So I'll just create a message that tells it to go forward with a specific speed and a round with another speed. So as we saw, the message, it has a linear part and it has an x, y, and z. So we want it to go forward. That's the x direction. I want to go forward with 1 meters per second. And also I want it to turn around the z-axis with 1 radian per second. Okay, so let's see how that works. It built. Perfect. Let's run it. And over here, let's see, we have the ROS node. Oh, that's also the Gazebo. That's why something went wrong. Let's just restart everything. Stop. ROS core again. Turn me around. ROS node list. Okay, so we don't only have the ROS round now. And we have the topic, command velocity mux input navi. So we can both, with this ROS topic, we can echo out. And you see it's coming out at 10 Hertz with what we actually set it to, but we can also see the frequency. Oh, what did I do there? Okay, so the frequency Hertz, and the average rate you see is 10. That's what we set it for, so makes sense, right? Okay. So let's now ROS launch the Turtlebot Gazebo. Right now the round is running, so it should actually be sending data to the Turtlebot. Oh, yes, it doesn't seem like Gazebo is really helping us. So let's just pull it down. Yeah. Control C to kill it, and I'll just try to, once it's killed, there it is, just launch it once more. Let's see if it works. It does so. And you see, actually, we have a Turtlebot that's turning round. It's turning round, but not in a circle as I wanted it to, but maybe I did actually command it to go a bit too fast on the angular movement. So let's see. Oh, this Gazebo is really not working good for me right now. Anyway, maybe I should try and update it. So let's kill it. Control C. And over here, let's kill our round, go into atom and just tell it to go a tad bit slower on the angular part. So 0.1 radians per second. That's really slow. Yep. Let's pull up the Gazebo again. And over here, oh, I didn't build it. So let's just cd into our workspace and click and build. That should work. It did. And let's run, turn around. It just turns around and around and around. That's kind of odd. So let's just open a tail operation node, because the tail operation takes precedence over the navi. So we have this command velocity mux input, and you can see that we're actually getting the right values, but something else is wrong. So if we open the Turtlebot tail up, that'll take precedence. Whoop, launch. There we are. Now press the O key to move it. You can see it's not working because the tail up information is taking precedence over our round. Oh, there we are. Now it's working, and it's making a big, nice circle. All right. So it's turning